Okay, all right, folks. Just like I explained before I started recording, this is the last lab, of course, one of the last labs that I sent you guys. And this lab is going over the TCP/IP model and the OSI reference model, and so that you guys can actually see it in action, right? The two objectives that we had to, I always have a tongue twister with that word. Anyway, the two objectives that we have to achieve, right, during this session is um, in part one, we're going to go ahead and examine HTTP web traffic, right? So we can see how that traffic looks. In part two, display some of the elements of the TCP/IP protocol suite, right? I know, I told you guys in the past, of course, what's on your PC is a TCP/IP model, right? I want to go ahead and correct myself. What's the correct terminology is what's used on you guys' actual PC and on our PCs is the TCP/IP protocol suite. Okay, where you saw that model breakdown and what have you. That's what our computers use. So just to correct myself and show you guys, of course, I'm not free of errors and mistakes and misspeaks and what have you. So hopefully I can go ahead and clear that up. Okay, so let's go ahead and jump right into it. Okay, so let's go ahead and take a look at web traffic first, as far as it covers part one, right? So in this lab, you see we have a web server, web client. Real simple, right? And so in the part of packet tracer, we have the section called simulation, right? And so what we're going to do is we're going to go ahead and switch from real-time mode, right? That shows the stuff in real time to simulation, okay? So we have it in simulation now, right? We are going to go ahead and just follow me here, right? We're going to go ahead and, select HTTP, even though it's selected, I'm going to go through selecting it, right? We're going to go ahead and enable HTTP as one of the protocols that we are going to filter, right? That we are interested in, okay? So we enabled that, all right? And so now that we enabled that and we have that configured, let's go ahead and start getting down and dirty, okay? Let's go ahead and start generating some web traffic. There we go, okay? I'm going to click on the desktop tab, okay? And I'm going to go ahead and open up a web browser, right? And I'm going to keep it this small, guys. And let me blow it up a little bit. Let me see if I can. All right. And I'm going to go ahead, right, and go to a website, right, that's configured on the web server, right? And pertaining to the lab, here's the website, right? We're generating, and we're going to go ahead and press play so we can start seeing it, okay? See that traffic, right? And you see it in the background, right? You're seeing the web client sending that message to the web server, right? The web server is sending that message back saying, hey, here's how it looks, right? Here's what you requested, and here's me presenting it to you, right? And this is where we're going to start talking about the encapsulation and de-encapsulation phase, okay? So now that we're done, okay, we're going to go ahead and pause it right here, okay? Let's go ahead and jump in, right, and look at some of these packets, okay? Uh-oh. Sorry, guys. PC's freezing up. I'm actually working on getting a new PC. Let's give it a second. Yep, good old freezing on a Wednesday morning. Nothing like it. All right, there we go. All right. Well, now my computer's done doing that. Now we can go ahead and take a look, right? So as you guys can see, right, within Packet Tracer, it's going to show you, and again, any protocol analyzer, like I told you guys, right, it's going to show you it's going to show you the results based off the OSI reference model, right? So things can make sense, okay? So what do we have here, right? We're looking at the PDU information, or the packets, right, that was sent from a source to a destination, right? Let's go ahead and decode all this, right? We see layer one, right? And this is, of course, we see in layers, out layers, right? So we see layer one, okay? Port fast Ethernet 0, okay? We see, of course, the layer two information, right? And just to break down what this means, right? This, again, in going out, this is the source, right? 0060.47ca.4DEE, right? Going towards, using the arrows, right? 0001.96A9.401D, right? Source and destination from a layer two perspective, right? Okay. And from layer three, right, we see that PDU information, right? We see the source IP, right, 192.168.1.1, going to the destination, 192.168.1.254. Again, that's at layer three, okay? Layer four, here's where it gets really fun, right? And it actually breaks down what's going on. And I know we haven't touched heavily on, the upper layers, what have you, because typically network engineers and people at the CCNA typically focus on layer three and below, if from an OSI model standpoint. But let's touch on this because this is important, right? Let's break this down what actually Cisco is saying, right? So let's read the PDU first. Layer four, TCP source port 1025, destination port 80, okay? Let's break down numbers 1 through 5, what that means. The device receives a TCP push plus ACK segment on the connection to 192.168.1.1 on port 1025. Okay, receive segment, right? It's called a segment because now it's at layer four. Receive segment information, the sequence number one, the ACK number one, and the data length is 102. Real in-depth information. I don't want you guys to remember that, but just keep following me, right? Right. Number three, the TCP segment has the expected peer sequence number, right? So what does that mean, right? So these two devices already started communicating, already started talking, and now they're they agreed on what they call a window size, right? To go ahead and send a size, the size of the amount of segments to send, right? That's coming from this PC, this web client going to that server, right? How big of that that segment is, right? And for it all to make sense, right? Let's say the segment is 5,000, right? 5,000 megs or what have you, right? It can't, it's going to negotiate with its, peer, right? And say, all right, I could only send 1,000, right, megs at this time, right? And if I have successful traffic that gets to the destination, I'm going to go ahead and increase this window size, right? We're going to touch more on TCP, right? But that's a super high level explanation of how that works, okay? So TCP IP, right? If you go back to number four, TCP processes payload data, okay? And TCP reassembles all data segments and passes to the upper layer, okay? And of course, the server receives a HTTP request, right? So again, it left the web client, and it's, this is from the standpoint of the web server de-encapsulating it, okay? I know I told you guys earlier that this is the PC. This is actually the web server on the end layers, right? As we can see, and again, it's been a while since I touched Packet Tracer and did the simulation. The last device is the web client, right? But this packet that we're looking at is on the web server side, okay? The actual out layers, right? The server sends back a HTTP reply to the client, okay? Right, TCP source port 80, destination port 25, right? And that's the port that's on the web client, right? To go ahead and make sure that traffic gets back to the source, right? Port 80 is always, port 80 is going to be used from the client side, right? And the port is always going to be different, right, on the server side, because again, it has to track that traffic, okay? Destination IP, destination source, you guys see, again, the source now, it's leaving the server and it's going to right where it came from, right? Going back to the web client, right? We see, of course, everything is flipped, right? What was here, flipped here. What was here, flipped here. Okay. All right. And let's break it down, right? Let's break it down. I know I went a little bit quick. So let's touch on layer 3, just like we broke down layer 4. Okay. Out layers, right? Leaving the device. The destination IP address is in the same subnet. The device sets the next hop to the destination. Okay. But let's break down layer 2, right? And this is my favorite layer, of course, in regards to troubleshooting or doing anything as regards to networking, right? Very important, right? And so if we're at layer 3, right, and we're still on the web server, right? This packet, we're still trying to decide where to send it to, and we know where to send it to, right? Here's what it's going to do. The web server is going to do, or any host is going to do before it sends it out on the wire, like I told you guys before, right? Per Cisco, great explanation. The next hop IP address is a unicast address. It learned that from the upper layer, right? The ARP process, right? We're going to talk about ARP later, looks it up in the ARP table, okay? I know I told you guys, right? These infrastructure devices, routers, switches, firewalls use protocols like ARPA, what have you. But our hosts, right, our PCs use them as well. Okay, they need to keep an ARP table to go ahead and be able to know, okay, this IP address correlates with this MAC address. Hopefully that makes sense. Okay, so with that, right? And so we're taking a look at that, and what the host is going to do is say, in this sense, the web server is saying, all right, the destination 192.168.1.1, right? Let me see in my ARP table if I know the MAC address for that, right? If I know the MAC address for that, perfect. I'm going to go ahead and set the destination MAC, right, to what I found in the ARP table. Okay, so now I can properly go ahead and encapsulate this payload from layer 3 into a layer 2 header and trailer. Okay. Once I go ahead and confirm that, package that all up, I'm going to go ahead and encapsulate it and go ahead and get ready to send it on the wire, right? And once I send it on the wire, I'm going to go ahead and send that frame out my interface, right? And so if we go ahead, right, we go ahead and look at this last device being the web server. We're looking at from the PC standpoint, right? We're going to go up, right, because we're de-encapsulating, right? It's received, right, right? It's received on port fast Ethernet 0, right? It's coming from, right? It's coming from our source, right? The frame's destination MAC address matches the receiving port's MAC address, the broadcast address, or multicast address, okay? So what does that mean, right? Um, this frame, right, that our PC heard, it matches our MAC address for our port. So we're going to go ahead and take that and de-encapsulate it, right? The source being that web server, okay? We ripped off the header and trailer, we're de-encapsulating it. Now we're looking at layer 3. Okay, the packet's destination IP address matches the device's IP address or the broadcast address, right? In this case, it's a unicast address, so it matches us. We're going to go ahead and de-encapsulate the packet, right? And go ahead and take a look at the segment, okay? Now, here's where it's getting fun, right? The device receives a TCP push ACK segment on the connection to 192.168.254 on port 80, right? This is where we started we initially initiated the session, right? We said, hey, we're gonna go ahead and reach out to the web server, right? Any, HTTP port 80, okay? And so we realized, right, what our PC is saying, we realized our initial session that we created is coming back, right, on port 80, right, from our source, right? Received, if we go down to number 2, receive the segment information. The sequence number is 1, the ACK number is 103, and the data length is 272, okay? We'll touch on that in the future, right? But just go ahead, keep on staying with me, okay? And so, hey guys, real quick, Gil is trying to join the Zoom. If somebody can send him a message and go ahead and let him know to join the Zoom invite, actually to go to the invite. Thank you. Yeah, Ryan, let him know to go to his Outlook and take a look at it. Thank you, buddy. All right. So then, of course, once we go down to number 3, right, the TCP segment has the expected peer sequence number, right? And so then, right, the PC is also going to do all its checks and say, hey, the TCP segment has the expected ACK number, right? It looks the same, right, from what I had. The device pops up, right, pops the last segment from the buffer, right? It's going to go ahead and process the data that's encapsulated, right, in layer 4, right, and go ahead and reassemble all the data segments that it got from its entire session, right? It's going to go ahead and say, all right, I got everything I need. Now I can go ahead and de-encapsulate to the next layer, right? And so now, right, once it does that, Gil, I'm going to go ahead and mute you, buddy. Once it does that, right, the web client, right, the PC on the right, it's going to go ahead and finally get that information, get the payload data, get that PDU at layer 7, and display that information it requested, right, as we saw, okay? And now we see, hey, we successfully touched the web server, okay? And so hopefully that made sense. Any questions, guys, right? This is how, and of course, within, this initiative or what have you, in the sessions that we have, we'll look deeper and deeper, traffic flow. I know you guys probably going to have questions about what you guys do at work and how would it make sense, what have you, when certain values change or what have you, and we'll touch on that, right? I just wanted to go ahead and review and show you guys how this works, how traffic works from an encapsulation, de-encapsulation standpoint, how it goes through the TCP/IP protocol suite, and how it actually goes through the, how you can look at it from an OSI reference model standpoint. How does that help you, right? It helps you in regards to if you're troubleshooting, right? Let's say, and of course, I like to start from the bottom up, right? If we're taking a look at the OSI model, right? I like to start at the bottom up, right? Hey, layer 1. Twan, I'm gonna go ahead and mute you. Okay. Layer 1, hey, do we have all cables plugged in? Is there anything going on with the device, right? Anything, right? Okay, we're good, right? Let's go ahead and go to layer 2, right? This is typically where your network admins that has access to the infrastructure devices, right? That's doing anything at layer 2, possibly switching, right? More than likely switching, is going to take a look and see, right? Can I see on this switch, can I see the downlink, right? Can I see the downlink's MAC address? Do I see the destination, right? Do I see the destination's MAC address? Where is it trying to go? If I don't, let's go ahead and go to layer 3, right? And if, right, another infrastructure device that's doing layer 3, I can go ahead and map and take a look and see him. I can go ahead and see, its ARP table, right? Which matches, of course, the IP address, to the MAC address, IP address to MAC address mapping, and go back and forth between layer 2, layer 3, right? And reverse engineer and see, do I have, consistent traffic flow throughout my network? Okay, if I do, right, using just these, right? And a lot of people get confused. Just using these values, not can I see a website or not, just seeing these values. Then we can go ahead and move up to layer 4, right? We can move up to layer 5, layer 6, right? And of course, that's the old joke that you guys hear about saying, hey, it's not the network, it's DNS, it's this and that, right? But of course, we have to prove this first. So in time, right, I'll have, I have fun activities that I'll send you. I know Twan can go ahead and speak on, some things I did in the past. As far as my spanning tree lab, I'll go ahead and send you guys some fun stuff, and you guys will see how to utilize some of these things. Okay, so again, real short lab. Didn't want to touch on too much. Any questions, guys? As far as the TCP/IP protocol suite, OSI reference model, how that traffic flows through a network. Because again, after this, moving forward, we're gonna, jump into high gear, touching on in depth as far as protocols and what have you.
I have a question, David.
Sure.
with the TCP IP stack or framework, why is it where they decided to go ahead, or rather, why is it shown that from layer 5 to 7 is just lumped together as, I guess, I believe it's like I think application, and why is it just lumped together like that as opposed to yeah, why is it just lumped together like that?
No, that's a good question. Let me look back on the historical information and the reason behind that. I don't want to tell you the wrong thing, nor do I want to tell you my opinion. Let me get back to you on that. Yeah, let me get back to you on that before tomorrow's session. Does that work for you?
Works for me. I'm with
Okay.
it.
Okay, cool. Any other questions? Okay. Like I said, this was just real quick. Tomorrow we jump back into theory. So real fun stuff. I say that super sarcastically. I know you guys don't want to hear about theory, but we have to, right? Because we all want to pass CCNA and you know, and become Jedis, right? Become Jedi Knights of this networking stuff. Okay. Well, you guys have a great day. I'll upload this soon, and I'll see you guys tomorrow.
Thanks, David.
Thank you, sir.